for 40 years. So I've been around the block just a little bit. I first learned the basic programming language in 1968. So there's always new things to learn, and that's what makes this business so much fun. I have been using SQL Server since 1992. Yeah, it was Sybase back then, but that's okay. It was still the same product between Microsoft and Sybase. In 95, I went to Microsoft SQL Server 6.0, and the rest is history. So anyways, here's what we're going to talk about. We're going to go through a simple ETL process for those of you who might be PowerShell junkies and haven't really experienced much in the way of ETL. We're going to go into a basic introduction to BIML, and then we're going to build our BIML script with PowerShell. So the simple ETL process, business is changing. We have to have a way that we can get our data from our transactional system into some form that allows our executives to run reports to see how the business is going. This has been around for a while. We have to be able to do this. You need to be able to capture those changes, and those changes can go into a data mart or data warehouse depending on your needs. I'm in the process of building a data warehouse right now for a package delivery service back in Cleveland, and it's a fascinating process. You have to be able to capture changes, and so that you get those changes into the data warehouse, and then management can run reports without impacting the performance of your transactional system, because that's what's happening right now at that client. So once they've got that data in the data warehouse, they can make those changes based on the current data, and everybody's happy. So how do we capture those changes? There's all kinds of different ways of doing that. We can use change data capture, which was an SQL Server 2008 enterprise level feature that they added. That's very effective as long as you do it correctly. There's change tracking. That's even available at the standard edition level starting in SQL 2008. You can put in triggers. The case in the company in Cleveland, I used triggers sending service broker message so I get near real-time ETL. But traditionally, we keep track of what the changes are, and on a regular basis run some type of extract, transform, and load process that gets that data from our transactional system into our data warehouse so the reporting can be done without impacting our transactional system. Traditionally, since SQL Server 2005, in the SQL Server world, we use SQL Server Integration Systems, or SSIS. How many of you have seen the series of articles that Andy Leonard created on SQLServerCentral.com called A Stairway to BIML? A few of you. All right. Excellent, because then you are already familiar with the incremental load package that Andy introduced in level 3. I talked to Andy. Andy and I are good friends. In fact, it was Andy that gave me the idea for this presentation. Andy came to Cleveland about 1.5 years ago, and he gave a presentation on BIML, just straight BIML, and I'd never seen it before, and I went, I can make use of that. So I worked with Andy, and Andy allowed me to use his demonstration of the incremental load package. So this is done with Andy's blessing. The idea is we have a table on our source database, and we have a corresponding table for reference purposes in our destination database. So we look at the source, we correlate the values in the source to our destination to see what's changed and what hasn't changed, right? And if there are new rows in our source that aren't in our destination, we add them to our destination. If they have the same rows, we then check to see if there have been any changes. That's the filter step. And if there have been any changes, we send those changes to a staging table from which we do a set-based update. Make sense? That's the model we're going to follow. So let's take a look at that. I have here in SQL Server two databases, SSIS incremental load source and load destination. If I look at the table in our source, there are 3 rows with IDs 0, 1, and 2. Col A has A, B, and N. Col B has a date time, and Col C has -1, 2, and 3. Our destination only has 2 rows. It has 0 and 1. Column A is A and C. Column C is -1 and -2. So this is what our data looks like at the beginning. These examples are taken right from Andy's Level 3 article, so you can download that and execute this yourself while we're doing this if you wanted to. Here's the package that he created. First, there's an execute SQL task that truncates a staging table for the updates. Then we go into a data flow that will load the destination table, and any modified data will go into the staging table, and then, of course, the final transact SQL statement that will apply those staged updates. If we look at the data flow, we start with a source. We correlate that source. So in that source, we have just the table name, our table source. Our correlate, we select the ID and the 3 columns from our destination. Oops. And we link on the ID column for our key, and then we look at each of the 3 individual columns there. If we get no match, in other words, the IDs don't match, we simply write those new rows to our destination. In the case of a match, we then go into a filter step that has an expression that says if column A not equal to column A on the destination, or column B not equal to column B on the destination, or column C not equal to column C on the destination. If that returns true, then we have what's called changed rows, and those get to staged updates, which we just truncated that table earlier, remember? And from the stage updates, we apply. That apply looks like T-SQL, doesn't it? A set-based update. So we get decent performance instead of potentially a row-by-row update. You have a question, sir? Why do we do this over a T-SQL merge? Depending on the size of the data, sometimes the T-SQL merge doesn't perform as well as this separate operation. So merge was a really great T-SQL statement that they introduced in SQL Server 2008, except when it comes to performance. Okay? It's that simple. We separate out the discrete components and things generally run better when we have production-sized data sets. All right, so just to demonstrate, we run the package. It ran. You can see we had 3 rows coming from our source. Let me see where I can expand this. We had 3 rows coming from our source. 1 row wasn't in our destination, so we just wrote it there. 2 rows matched. 1 of those had changed. If we go back to our database and execute our queries, you can see now that they match identically. Now can you see it? Identical rows, identical situation. So this is our incremental load model. We're going to use that model in our project. So I'm going to close that out. BIML, Business Intelligence Markup Language, was originally a project developed by Microsoft called Project Vulkan. They even released it to Codeplex, and you can go check it out. It's vulkan.codeplex.com. The problem is Microsoft said, we don't really have the resources or the desire to pursue this to its logical path. So they released it to Codeplex. Scott Curry, who was one of the people that was working on that project, after 7 years at Microsoft, he left Microsoft, founded a company called Verigence, and started working on that same idea. So he uses the same concept in BIML, and he released a project to Codeplex called BIDS Helper. It's free. bidshelper.codeplex.com. You can download it, install it, and then you'll have the BIDS environment available to you in SQL Server Data Tools and in BIDS if you're running SQL Server 2008. All right? So he didn't use any of the code from Vulkan, but he used the idea, and he's off and running with it. So it's an XML-based markup language, just like HTML is an XML-based markup language, right? It's an XML-based markup language that allows you to define a whole lot of different things I've just learned in the last 2 days. Up until yesterday, to me, it was a way to create SSIS packages very quickly. As of yesterday, I found out it does a whole lot more, and it's really, really cool. So I've got some other ideas that I want to pursue when I have some time. So this is basically what BIML looks like. Again, it looks like XML. Does my, oh. Can everybody see the BIML on here? We have just the basic. When you open up a BIML file, you get a tag that says BIML, and then an attribute called the XML namespace with a reference back to the Verigence site. We can add packages. So we add a packages tag. We add a packages tag right there, which allows us to define one or more packages. Then each package, we give it a name and a constraint mode. Those two properties are required. And then when we've defined everything in the package, we end the tag for package. We open up a new packages, then we end the tag for packages, and we end the tag for BIML. We can add connections at the project level. There's a connections collection, if you will. I like to refer to these as collections. So I've got a connections collection, and then individual connections, which are simply connection strings. You guys go to connectionstrings.com? Yeah, me too. So I just put in a connection string, and that defines the connection. Then I can use that connection in a variety of packages, right? So this is simple BIML. I put together a little bit of a hierarchy because I went to Verigence's documentation site, and it's very complete and very complex and very confusing. So I like to put things in object hierarchies so I know where to go. So I start with the level called BIML. Underneath that, I need connections for the connections my packages are going to use. Then inside each package, I define my connections and my tasks. Inside my task object, I can do an execute SQL task. I can do a data flow task. I can specify precedence constraints. So do you remember the path that we followed in that data flow? Well, the precedence constraint allows us to define that. And then, of course, we need transformations. And inside the transformations, because that's where the real work gets done in SSIS, we need a source and a destination, and perhaps some work that we're going to do in between, in this case, a lookup. So this is just a general object flow, if you will, a hierarchy diagram. Yes, sir? I'm sorry? Is there no upper level for a project? I can't answer that. I didn't need it for what I'm doing here. So it does support package projects. So the hierarchy does support package projects. I tried to keep things simple for this diagram. It's not a complete diagram. And I'll give you a link at the end of the deck to go to Verigence's documentation website so you can explore through that yourself. Okay? So let's take a look at BIML. If I go back into Data Tools, we'll end this execution. Does that look familiar, Andy? Andy Leonard walked in while we were in that last piece of discussion. So I can go into Solution Explorer, and I can right-click on my project, and I can say, because I've already installed BIDS Helper, yes, because I've already installed BIDS Helper, I now have extra options inside SQL Server Data Tools. One of them is Add New BIML File. So I do that, and it always names it bimlscript.biml. I can open that, and what does that look like? It's the same thing I showed you in that last slide, right, with just the basic BIML stuff. I can go to the end of that line. It automatically indents for me. I start a bracket, and I get IntelliSense. Here's all the things I can do just underneath the BIML tag. So I can say connections. If I close that tag, it automatically closes it for me. If I open another tag, it opens and gives me, through the IntelliSense, the kinds of things that I can do inside the connections collection. I hit space. Well, of course, my connection wants a name. If I close that, it closes that, and I can add more, and I can keep typing, and this is the environment that I get for free in BIDS Helper. I have another one here that I'm going to add. So I can right-click on my project and say Add Existing Item, and I'm going to go into my demos directory here on my machine, and I've got a file called BIML Beginner. All it does is generate a package. So I can right-click. I can right-click on BIML Beginner, and I've got an item here because I've loaded BIDS Helper called Generate SSIS Packages. I select that, and I now have a new package here called BIML Beginner. Now, because I didn't put anything else in the BIML, it didn't do anything. It's just an empty package. But that's how easy it is to generate a package in BIML. The incremental load package that I showed you came from this script that Andy created, that Andy posted on, along with his Level 3 incremental load article on SQLServerCentral.com. Essentially, we start with the header. We've got connections for incremental load source and incremental load destination. Oops. Again, going against the local server, and the catalog just gives it the name of the database. We then have packages. There's only one package. It's the incremental load package. Constraint mode in this case is parallel. If I have more than one package, this will run in parallel with others. This protection level item here says encrypt sensitive with user key. Now, this is not the default when you create a package, but it is the default at the project level when you create a project. And by specifying protection level increment sensitive with user key, it prevents an issue that occurs with attempting to execute a package when the protection level is not properly set. And this was, what level of SSIS did this start in, Andy? You've always had package protection levels. So it was SSIS 2012 that added the project level protection. So that's why this is specific for SSIS 2012. Underneath that, we're going to execute some tasks. We have our first task is our truncate stage updates task. It's an execute SQL task. And the code for the execute SQL is in the direct input tag where we put the T-SQL we're going to put in the execute SQL task. It's for direct input. And we also need to specify the connection name we're going to use. So it's SSIS incremental load destination. Underneath that, we have a data flow. That data flow has as its precedent the output of the truncate stage updates task. Make sense? Simply drawing that green line down. That's all it's doing. Once we've defined our precedence constraints, then we can define our transformations. We start with our OLEDB source, which is our table source is the name of it, and it's the connection, our source connection. And we're simply bringing in the dbo.tableSource table. This is why I dislike using TBL at the beginning of table names. I just don't like it. It gets the table called the table. So then we have a lookup. This is the correlate step that we talked about earlier. We look into the destination, and then we have our selection, col ID, col A, col B, col C, via direct input. Then our inputs to that correlate step, we need to define under inputs, we define the key column, col ID, and under outputs, we define our 3 data columns. Our source column is the name of the column coming from the source, and then we alias, using target column, the name of the column on the destination. That's the end of our lookup. Then our destination, our OLEDB destination, is again our destination connection. We specify that. The input path for this step is the correlate no match. So when we have no match between the source, oops, sorry, that's gravity working on my mouse. When we have no correlation between the source and the destination, we follow the no match path, and it simply outputs our data to our destination table. But in the case of where there is a match, in other words, correlate.match, we go to the filter task. Where are you? There you are. In our filter, our output path, of course, is changed rows. Here's our defined expression where we say column A not equal to destination column A, or B and C, etc. And then we specify, that's our conditional split, so we decide where that data is going. And then the output path following the changed rows path simply says write those rows to our staged updates table. So anything that changed between the two goes to our stage updates table. And then we leave the data flow, and we have the execute SQL task, and here's the code that I showed you in the model, right? It's the exact same thing. So if I go back in here into Solution Explorer, and I delete the incremental load package, and I go back into my database and reset the database, and you can see, and I'll give you all these scripts. I'll post these. Today I posted a blog post where I posted the hashtag for your questions. I'm going to update that blog post later on this evening and add all of the demos, all of the scripts here for you. All right, so now if I run that query, you can see we're back to our original state for our data. I can right-click on incremental load BIML, generate SSIS packages. There's that same package. If we run it, what? Oh, sorry. Let me fix that. And we get the same results. We go back to our database, and our tables match. All that makes sense? All of that is in Andy's article. If you want this, down and dirty detail of that whole process, it's in his article. And he did a great job writing it, and I thank him for allowing me to use this as my model for where we're going to go next. Anybody who knows me and has been to any of my presentations knows how much I love PowerShell and SMO. SMO is Server Management Objects. It's the management API for SQL Server. It was introduced in SQL Server 2005. It still is valid through SQL 2014, and it supports all SQL Server databases back to SQL 2000. So we have this tool that allows us to explore SQL Server. When you connect to a server via SMO, you connect to a server object. Now, PowerShell is not an object-oriented language. It is an object-based language. So we deal with objects in PowerShell, and the topmost object we'll connect to in SQL Server is the server object, and that server object represents an instance of SQL Server. So we'll connect to our server object. Underneath the server object is a collection of databases. And in that database, and each database, there's a schemas collection and a tables collection. The schemas, of course, define the various schemas that are there, and the tables that define the tables. Underneath the tables collection, we have each table. It has a name property, it has a schema property, and it has a columns collection. Inside that columns collection is a group of columns that have properties for name, for data type, for default, for whether or not it's an identity column, whether there's a rule associated with that column, etc. These are all properties that are there that we can use to get where we want to go. PowerShell, because PowerShell sits on top of .NET, we have access to all the stuff that .NET gives us. And one of those things is a very cool namespace called XML Text Writer. Now, I just showed you BIML, and it was XML, yes. And so now I have a way to create XML without doing all kinds of crazy string stuff, right? Now, you might think this is crazy by the time we're done with it, but I thought this was pretty cool. And I actually learned about this from one of the PowerShell MVPs by the name of Jeffrey Hicks. Jeffrey Hicks co-wrote many books with Don Jones, and the one I highly recommend if you're brand new to PowerShell, it's called PowerShell 3 in a Month of Lunches by Don Jones and Jeffrey Hicks. And that book will take you from raw beginner to functionally useful with PowerShell. You'll be able to do the things that you really need to do, as long as they're not too advanced. And then there's other books beyond that will take you to more advanced levels. But the XML text writer object namespace gives us the tools that we need to create the XML to generate BIML. Now, because we're not truly generating XML, we don't need that XML header. We'll start with BIML as our start tag. But by specifying the right properties in XML text writer, we can properly indent our information using the formatting and indenting properties. We use the right start element method to create our start element, like BIML is a start element, right? Connections is a start element. Tasks is a start element. Attributes, so at the very top we've got BIML. That XML namespace is an attribute. So we have write attribute string, allows us to specify those attributes. And then, of course, we have to be able to write the end element. So we need to plan our ETL process. We want to define our staging tables in our data warehouse, right? We can define, now this goes beyond where my original thought was, let's do the whole Kimball thing. It got a little bit more complicated, and that's probably a whole day process instead of a 90-minute session. But the way I would go would be create a couple different patterns. I'm going to show you one pattern, the pattern that follows Andy's incremental load. And I use that pattern for what I call reference tables. Tables that I put into the data warehouse that are won't be part of the dimensions or facts, but are things that the dimensions and facts rely on for data, and I don't want to go back to the original database to get them. Does that make sense? I call those reference tables. Other people may call them something else, but I call those reference tables. And I'm also going to define a dependencies table so I can define what tables get referenced from source to destination. And also, I define the ID column, so I don't have to guess. It doesn't have to be the first column that I run into in my project. All right, so I want to know the source, the destination tables, and what the ID column is. So what we're going to do is the process of generation, just like you saw in the incremental load BIML that I walked you through, we're going to connect to the source and the destination servers using SMO, server objects. We're going to connect to the source and destination databases, again through SMO. We're going to load the dependencies table into a data table using the SQL Server invoke SQL CMD commandlet. I did write a white paper on using PowerShell with SQL Server. I wrote this back in 2009, and it's out on MSDN, and I think I have a reference to that if you want to get started with SMO in PowerShell. So using invoke SQL CMD, the data that comes into a data table. Once we have that information, we're going to write the BIML header, we'll write connection objects, and then for each table in that source database, we're going to find the destination table in the dependencies. We're going to do a column for column match, so we don't try to update columns that don't exist. We're going to discover this as we go through, and we're going to build the data flow objects from that. You ready? Yeah. I like your enthusiasm. That's wonderful. All right. That's not what I wanted to do. Resolution, resolution, resolution. I have right here a script. It's just simple script called BIML Beginner. Remember I showed you that that BIML Beginner package? Okay, this generated it. I wanted to show you this because if I don't show you this, then actually using the XML text writer in the context of creating all that BIML for the incremental load might lose you a little bit. So what I'm going to do here is I'm going to instantiate, using the new object commandlet, I'm going to instantiate an object of type XML text writer. The first property is the full path of the destination file. Where am I going to write this to? I'm going to write it to cdemos bimlbeginner.biml, right? So I've instantiated this new object, and I put that object in a variable called $BIML. I know, I'm not at all original. I've defined my formatting as indented. My indentation for each level is 1. Who wants to go crazy with it? My indent character, this is a PowerShell convention. The backtick is the escape character in PowerShell. So we use a backtick T to indicate a tab. But PowerShell has 2 ways of identifying a string. You can use single quotes, or you can use double quotes. With single quotes, PowerShell just takes verbatim what's inside that quote string as your string. And what we end up with in our result is a backtick and a T, 2 characters. That's not what I wanted. I wanted a tab. By using double quotes, PowerShell does variable substitution. So I could put a PowerShell variable in there, and it would interpret that inside my string. That comes in really handy for connect strings, and we'll see this in the code. But it's also necessary when we're doing a special character like this. So we use a double quote so that it interprets that backtick as an escape character to tell us that we want a tab. Once I've defined the XML properties for the XML file I'm going to create, I can start writing my XML. So I'm going to start with the start element, BIML. It needs an attribute. That attribute is XML_NS. And the value along with that attribute is that URL to the Variagent's namespace for BIML. What I realized really quickly, I need to have an end element for that BIML object. So how many of you guys wrote Lisp, the language Lisp? A few of you. Wasn't it fun figuring out how many right parens you needed? Yeah, exactly. Those of you who've done Lisp get that. It was kind of crazy. Lisp was a wonderful language because it really taught me recursive programming. Okay, and that's the best thing I got out of Lisp. The worst thing was a fear of right parentheses. It's kind of the same Whoa, lost my screen. There we go. It's kind of the same problem here. I need to know that I need to end that tag. So what I started doing was I put in PowerShell comments saying end and whatever tag I'm working on, so that all I have to do is start inserting lines in between. As soon as I create the start element, I create the end element with a comment indicating when I'm ending. Okay, that's just a convention I started doing so that I wouldn't lose my place. So, once I've got my start tag for BIML, I need my start element for packages. There's my end element for packages. A start element for an individual package, then its name and the name of the package, constraint mode, and its value, in this case parallel. If I go back into this directory and delete my BIML beginner output, and I go into PowerShell, you guys have seen PowerShell before, right? Oh, that's interesting. There we go. Let me increase the font for this because that's not really good. How's that? Is that better? All right, I'm going to change into my demos directory. Yes, I use ls. It's an alias, forget child item, as is dir. So what I want to do is execute the new BIML beginner script. And there's my BIML beginner script again. And if I open that with Notepad, does that look familiar? Okay, so now you've seen how I use the XML text writer. So now we get to get into the real fun code. You've already seen me use this, right, to create the package, so I don't need to go back and do that. All right. I have a script here called new BIML from DB, and this is our destination. Now this looks a little different right from the beginning. Those of you who have never seen PowerShell before, please, please, please adopt a coding standard like this. The very first thing we have is a multi-line comment in the format that starts with the word .synopsis and then a brief description of what the script is going to do, and then a dot description with an extended description of what the script is going to do. And then it follows with dot example with an example of how to use the script. How does that come into play? You ask. In PowerShell, there's a commandlet called get help that gives you help on all kinds of things. Now, one word of warning, PowerShell 3.0 introduced a new way of dealing with help. Rather than loading all of the help for all of the commandlets for all of the languages, when you install PowerShell, it doesn't install any of that. It doesn't install any help. Use the update help commandlet once you first go into PowerShell on a machine, PowerShell 3.0 or greater. It will then go out to Microsoft and get all of the help for that version of PowerShell from Microsoft in the appropriate language for your computer's environment. And then, when there's a change to the help, because it's software, you can update help again, and you'll get constant updates from Microsoft on the help. All right? That's to save you space and to allow them to get you updates on how things work. Somebody way in the back had a question. Great. So, get help allows me to use that help, but if I've put that those comments in the beginning of my code, look what happens. I get man-style help from my own script that I embedded in the code. It gets even better. Because in my script, I added comments before each parameter that I can pass into the script. I can add the dash detailed option, and it gives me back my parameters along with the comments I put in my own code. So I'm documenting for the user as well as myself what's going on inside that script. Please adopt this for a standard for yourself. You notice the example here? Shows you how to use the script. So that's the first part, is my comment-based help. Then I need parameters. Commandlet binding allows me to incorporate some of the special features that PowerShell provides. And I'm going to forgo that. I'm going to have a blog post coming out fairly soon on this particular option in detail. But for each parameter, I'm specifying that it is in fact mandatory. I specify the data type and an initial value. Because I've said mandatory, if I don't supply the parameter when I run the script, PowerShell will ask me for a value for that parameter. So it walks me through it because I've said this has to be here. So I'm specifying the source instance, the source database, the destination instance, the destination database, and the output BIML file in its full path. This, I'm sad to say, I'm still stuck on PowerShell 1.0 error handling, but I have error handling in there. .NET provides errors, but it's a hierarchical structure. And the top level error doesn't give you a whole lot of information. It's the innermost error message that gives you all of the information you need to fix whatever problem it is you have. So this code just loops through that multi-level structure to present to you all of the messages associated with the error, and I've just continued to use this since PowerShell 1. This next piece of code won't work on a SQL Server system where you've only got SQL Server 2008 installed because they changed the rules between SQL 2008 and SQL 2012. PowerShell 2.0 came out in 2009 and introduced the concept of modules. And the PowerShell team said, everything you do from other server systems through PowerShell should be done in modules. Well, 2008 was already out. And the previous way to handle things was what was called a mini shell, where you add snap-ins to PowerShell. So there are SQL Server snap-ins that came out with SQL 2008. If you look on your systems that are running SQL 2008, you'll find an executable called SQLPS.exe. That's PowerShell 1.0 with the SQL Server snap-ins already added in. And I've also blogged about a way to add those snap-ins into your current PowerShell environment if you're still using SQL 2008. SQL 2012 came out after PowerShell 2 came out, and they said, okay, we'll create the module for you. So they created a module, called it SQL PS. And they did something that violated another issue, a little thing that they added in PowerShell 2. PowerShell 2.0 introduced a defined set of acceptable verb names. Commandlets in PowerShell use a verb noun naming convention. And they created a list of acceptable verb names to prevent you from writing functions that said, kill this process, terminate this process, destroy this process. In PowerShell 1, those were all valid verbs. In PowerShell 2, I think it's stop. Stop process is the acceptable verb name for that. The problem in the SQL Server world for this is that they didn't add two important verbs to DBAs, to that acceptable list. Backup and restore, right? So what we have to do is we have to import module name SQL PS, and we have to add the disable name checking option to that so we don't get that ugly message saying, hey, you're not using acceptable verb names. Okay, that's what that's there for. The other thing the SQL Server team did that kind of violates the PowerShell protocol is that when you import the module, SQL PS, when you're done with it, it leaves you into what they call the SQL Server provider. The SQL Server provider allows you to navigate SQL Server as though it were a disk drive. Yeah, it's kind of cool. And there's a lot of really good use cases for it outside of this context. However, it's not a good practice to leave you there because I expect when I import a module to be right back where I was when I started. So my code, I added a push location commandlet before I input the module that says take wherever I am and put it on the stack, import the module, and then pop location, which redirects me right back to where I was from that location I put on the stack. Excuse me. So that's what this piece of code right here does. The next two pieces of code, once we've loaded the PowerShell, the SQL Server module, we now can instantiate a server object in PowerShell. So we're going to use the new object commandlet. The object type is Microsoft SQL Server Management SMO Server, and we specify our instance name for our source instance. We grab the databases collection and we look for the source DB in that databases collection. So I now have a variable called SDB that is the object for my source database in SMO. I'm going to do the same thing for destination against my destination server and database. I now am connected to both instances of SQL Server and both databases. This construct, starting with the at and the quote, ending with the quote and at, in PowerShell is called a here string. And inside that here string, I've simply put in my T-SQL for getting the information out of my dependencies table. If I go back to, sorry, I have to, again, you'll have all of these scripts. So if I go, let's shrink this just a little bit so I have a little bit of real estate. Yes, sir. Oh, it's there. Okay, good. So I'm going to create my source database and my destination database. I don't need this anymore. And if I refresh my databases, my source database is going to be called Northwind. Remember the Northwind? I cleaned it up and made it a little simpler for this purpose, so you can use my scripts to create the Northwind and Northwind Data Warehouse databases. But it's just a set of tables in the source database, and the destination has got a little bit more to it. It's essentially the same set of tables. The reference tables are my destination. These are where I'm going. The reference tables are my destination tables. The staging tables are, of course, my staging tables. But it's the same model as the incremental load we looked at earlier. The last thing is in the DBO schema, I've got a dependencies table. Inside my dependencies table, again, source schema and table is listed here. Destination schema and table here, and the key column. So this is the driver for the script. These are the tables that we're going to build packages for to copy from one source to the other. The other thing I'm going to think of to do right now while I'm thinking about it, I've got a BCP script that loads the data into those tables. So now we have data in them to look at. Yeah, I still use BCP. I told you I've been around for a long time, didn't I?
While that's loading down, there were 2 questions.
Okay, 2 questions from Twitter.
They were answered on Twitter already, but so we can hear them. One, for the first one, can we use custom SSIS tasks like those from Codeplex?
The question is, can we use custom SSIS tasks from Codeplex? And the answer is yes, of course.
And the second one is, can we use script tasks with BIML?
And the second is, can we use script tasks with BIML? And the answer, of course, is yes. I highly recommend, Andy, do you have a session coming up later this week that you're talking about BIML? Not here? Darn. Darn. All right, so this query right here grabs our dependencies table that I just showed you. And it loads that as a data table into this variable called DEP. You guys have seen this code already. I'm now going to create a string variable, one for each of my connections, called source connection and destination connection. And remember I talked about connection strings? That's all it is. It's a connection string. But there's my double quote. So I'm using variable substitution, and I'm using the variables that I passed in for server and database names. So I'm defining those connection strings based on what was passed in through the command line arguments. So I start my connections, tag, add the connection for source database and the connection string there. I've got a connection object for my destination. There's the destination database and the connection string for that. And I'm done with my connections in my BIML script. Now I can start defining my packages. So here's the header for the packages object. Because I've got a data table, I can iterate through that data table for each. $D will be the iterative member of that collection. So each $D will be each individual row that comes back from that dependencies object. And I'm just, for simplicity's sake, because multiple references gets very confusing in PowerShell, I'm going to say my source table is source name, my source schema is source SCH, destination and destination name and schema there. My key column is here. And I'm going to call my package name my source database name underscore my source table name. That's the name of each package that I'm going to create. Then I'm going to look into the tables collection, because unfortunately, when they created SMO, they didn't take into account the schema part of the name when you're trying to index into a collection. So what I have to do is I have to take the tables collection associated with the database and pipe that to a where object commandlet and say where the iterative member's object's name is equal to the source name, the table name, and the schema property is equal to the schema that I passed in. It's a little less clean than it should be, but it works. So I now have in STBL the SMO table object for my source table, and in DTBL I have the SMO table object for the destination table. Now, it gets even more fun. I'm creating here with the @ open and close parentheses an empty collection. That collection is going to be called $COL, and that's going to contain a collection of the columns that have matching names in the source and destination. Because I might have differences, right? So I want to keep track of the columns where they're the same on both. So I go through my source table, and for each column in the columns collection in my source table, I'm going to grab that column's name, put it into the COLNM variable. I'm going to index, because I can with the columns where I couldn't at the table level, I'm going to index using the name of the column into the columns collection and bring back the result as an object, a column object for the destination table. But if I didn't find one, my count will be 0. So I look at the column count, and if it's greater than 0, that means I found it. I'm going to create a system.object in a variable called mColumn, and I'm going to pipe that to the add member commandlet, because I want to add a member to this object of type note property. The property name is going to be name, and the property value is going to be the name of that column. I'm simply creating an ad hoc object on the fly here, and I'm going to add it to my columns collection. Does that make sense? Cool. So now when I get through this loop, I now have a list of the valid columns that exist in both source and destination. If I wanted to enhance this script, I could add comparisons to make sure that the data type is compatible between the two. I didn't want to get it too complicated. This works for demonstration purposes. All right, now I need to pull the data from the source table. Remember, we saw that in the package where we're pulling the data from the source table. Actually, we're selecting from the destination table. So my comment is incorrect here. It is the destination, and I'll fix that before I upload it. So I'm creating a T-SQL select here, select, and I'm specifying here in CNT is the count, right? The number of columns in the table. And then I'm initializing a counter to 0, and then for each column in that matching columns collection, I'm going to add the name of that column to my source query. So if the column name is col ID, I now have select col ID. I increment my counter, and if my counter is not yet at the number of columns in my matching set, I add a comma and a space. So I iterate through the columns, adding the individual columns to my select statement. And when I'm done, I say from my destination schema dot my destination table. So now I have a select that selects against my destination that I can use for the comparison between my source and my destination. That's now in the variable called source queue, which is really wrong. It should be destination queue. So now I can start my package element. This is per table. I've got my execute SQL task. The task name is truncate staging underscore table name. Connection name is my destination database. Direct input, truncate the staging version of that table. Then I start my data flow task. We've already gone through this logic, right? So we've got our data flow task. It's called load table name precedence. It's the output of the truncate task, just like what I showed you before. We've got our transformations, OLADB source, our source name, and we call it the source name source. The connection name is our source database. External table input, we start that tag, and the attribute is pull that data from our source table. Here's our correlate lookup object, our lookup task. OLADB connection name, it's going to look up against the destination DB. The no match behavior is redirect rows to the no match output. Our input path is the output of our source from our source table. The output, then our direct input, this is where we put in that query against the destination table. And here's where we write that query we constructed just a moment ago. Our inputs, remember we had col ID is the input and the individual columns is the output. So under inputs, here's our key column, source and target. Matches that pattern we used before. Then for our outputs, we go through our collection, and as long as the column name is not equal to our key column name, we grab the name of the column, we specify the column name, our source column being the column name, our target column being destination underscore column name, and that element. So that's how we build that lookup, or that transformation. Then we have our OLADB destination. It's the table name destination. Here's the destination database. The output path name is correlate no match, and we specify our destination table right there. That's finished, and we do our conditional split. That takes us to our filter. It's called filter. The output path name is correlate match. We start our output path tag there, and then we need to build this expression. Building this expression is the same basic logic that we used in building the select statement. We go through each column, but in this case, for each column that's not a key column, we say where the column name is not equal to the destination column name, or column name not equal destination column. So we iterate through the columns, building an expression that compares each column, source to destination, and the end result is a long version of that same expression I showed you earlier. We simply put that whole expression in this variable called $exp. We end all of those tags. You notice all of my comments, so I keep track of where I am in the script. And then the output of that, of the no match, of the changed rows coming out of the filter, is our staging table. The same table name, but in the staging schema. And then we come out of the data flow, we've got our execute SQL task to use the set-based update. And again, I go through that columns collection and I build a set-based update statement using those same columns. Does that make sense? Because it was a little interesting making this happen, but it all formats itself out rather nicely when I'm done. So I've done all of the stuff I need to do there. I'm now at the end of the loop of all of the tables right here. Oh, but there's one more step. This last step, do we want to execute each individual package every time we run our ETL? Of course not. We want a master package. So I create a master package. I call it the source database underscore master. I go and create tasks, and I create a container. I put all of the tasks, the execute package tasks, in a container called source_db underscore ETL. And then for each table in my dependencies table, I grab the name of the source table, because that's what I used when I was creating the packages, and I create an execute package task with the name of that table. I use the external project package, and this works, and specify the package name as source_db underscore source name .dtsx, which is the name of the package I'd already created. We close all of our tasks, and we flush and close our XML. That's the script. And I know I lost some people in the process because it's really hard sometimes walking through script code. However, let's actually play with this. So I already showed you the help, right? So now, new BIML from DB, source, instance, source database, destination instance, destination database, and the full path to the destination BIML file. We'll call it nwetl.biml. Unfortunately, that's scrolling off. There we go. .biml. Now, I did not load the SQL PS module before I ran this script. So that warning we got is telling me that I don't have an active instance of analysis services, so it can't load those objects. I don't care. I'm not using analysis services right now. It's okay. But we're already done. And so what I have, what did I call that? nwetl.biml? There's nwetl.biml. I can open that with Notepad. Here is, I'm going to against DBO categories. Here's my select for category ID, category name, and category description from reference categories. There's my update statement from the staging. It just generated all of the BIML for all of those tables. So what can I do now in Data Tools? First, stop the package that's still running. Go in and add existing item. Right-click and add NWETL. Right-click on that and generate SSIS packages. And there they are. An incremental load ETL package for every table I specified in my destination, in my dependencies table, and a master package that executes all of them. So if I look, thank you. So if I run that, I can run right here and do reports, standard reports, disk usage by table, depending on how fast the packages are running. Yeah, you see there's no rows in any of the tables. We'll go back to see how it's going. It's still running. While it runs? 2 questions, okay. The first question is, can BIML handle event handlers and logging? And I'm going to say yes. Andy, yes, yes. The second question is, can you give some real-world examples for uses for this? Andy, would you like to come up and talk? Since I stole your idea, would you like to share some real-world examples of how you're using BIML? This one might work. Yeah.
I'll try that. Thanks, Alan.
This is Andy Leonard, and again, it's Andy's article, The Incremental Load Project, from which I took the model for what we just saw.
I appreciate the opportunity. So there's a real-world project that we're doing right now for an insurance company. We're staging data, and we're using BIML in a lot of places, but probably the best way to talk about in the context of this example is we're staging data from anywhere from 40 to 120 tables in a subject area at a time. Data staging is pattern-based. For most of them, we're using truncate and load, so it's an ELT, extract, load, and transform pattern where we wipe out the destination and then load it each time. Typically, when you're doing an ELT pattern, the packages are relatively simple to write. You can write them in 30 minutes, maybe 45 minutes. If you're doing an incremental load pattern, it's often more difficult because of the extra code. It's about 2 hours per package. So what we've been able to do is create a project using the product MIST that is a for sale product that allows us to create MIST projects, and we can automate a lot of this. We're doing, from just a purely BIML standpoint, we're doing what you're seeing here, but we can add some automation using MIST, and we're able in about 5 minutes to regenerate 40 or 80 or 120 packages that are doing incremental loads. So when our source schema changes, we don't care. From a staging standpoint, We just go in and regenerate everything from the get-go. And what that's allowed us to do is probably that's part of the reason why we're under budget and on time for this project. We don't have to spend, 160 hours generating incremental load packages. We're able to literally do that work in about 5 minutes. But it's pretty game-changing real world. Is that a question for me or for Alan? Okay.
So for the audience at home, the question is, what do you do when you need some kind of a warning so that some kind of column has changed so you need to update your incremental load packages. Andy, you actually told a really good story about this, the 60 and 61 story.
Yeah.
If you would, please.
I did. So the short version is if somebody makes changes to the source schema, and that was happening to me now, before MIST and BIML, I could be reactive to that. And I created a metadata collection package that would go out and look at my sources, collect that metadata, and bring it in. It was relatively slow and cumbersome, but it would store a list of the last version, of course, and then the current version, and I would do a store procedure compare. If there were any differences, I would actually shut down execution. And I had someone, I suspect, being a little malicious or just at least devious, making changes in the source. And I was able eventually to catch them that way and basically provide that report to the end user. With MIST and BIML, especially now with BIML, I'm not as concerned about that anymore because I can be proactive, at least from a staging standpoint. I can go regenerate like the staging packages every night before I execute them. Because I can go read against the source, and if they add a column or if they change the data type on me, I can now read that information in. Now, a robust production version of that goes well beyond what we can discuss here as an answer, but that's the important part of the paradigm shift that BIML enables.
There's a question back here. The question is, how do you automate the generation of the SSIS packages every night?
That's magic. I'm kidding. If you...
By the way, under my solution, SQL Server Agent has a PowerShell task type that you could use to run this script that would regenerate the packages. But I'll let Andy answer the way he's done it in production.
That is one of the solutions, is you can actually use PowerShell once you've got a full license for MIST. You can do that to generate it using the MIST API. What Alan is doing is not using the MIST API. He's actually leveraging PowerShell, and he's creating a lot of the same functionality through PowerShell. So you could do it the way he's doing it. You could, with a licensed version of MIST, you could actually go against the API and schedule it like a job. I think so. I'll
repeat
say
his
that.
question.
So your question is, if I heard you correctly, is that we're using PowerShell to create the BIML file if we wanted to automate the regeneration of the SSIS packages from BIML. Is that correct? Right. I believe you would need the license to do that. And I'll tell you this, Alan is a very good developer and a very clever software architect. I'll bet he can figure out some ways to do this sort of stuff. But I know for a fact the way that we're doing it when we do this is we're actually pinging against the API that ships with MIST. And it is, the gentleman who wrote this is Scott Curry. Scott was with Microsoft's Visual Studio team for 7 years, and he worked on C++ compilers for that. So he's very good at creating APIs. That's what he did for a living for a while. And he's exposed this whole API. Now you have to buy the product, of course, to get that extra functionality. But even if you're not using that, what Alan has demonstrated here, I find is very compelling. And I've used this in several rapid application prototyping scenarios, exactly what he's shown you here.
Yes, sir.
If you already have a template staging package, can you reverse engineer a BIML file?
The question is, if you already have a template staging package, can you reverse engineer it? And the answer is yes, with the commercial MIST product. What I did with Andy's is I just went through the BIML that he had created and walked through it. So it's a matter of understanding that internal structure. But yesterday I sat in on the BIML workshop that was put on by Andy, Tim Mitchell, and Scott Curry, and the people from Verigence. And I loaded a trial version and reverse engineered a package into the BIML from that. So you could buy a 1-month license for MIST for $250 and convert all of the template packages you want into BIML and then not pay any more money, and then you've got your source BIML.
Actually, don't tell Verigence
Don't.
this. You can download the trial version. It's fully functional for 14 days.
Yeah, it gives you 5 conversions.
Does it? Oh, it only
It,
gets...
it limits you to 5
I'm
conversions.
sorry. Thank you.
I figured that. I
Thank
found
you,
that
Alan.
out.
Thanks for pointing that out.
So, but just to, we've got just a little over 5 minutes left. This is a spotlight session, and I thank you guys for staying for that. I did want, you see the row counts now are, the data's complete. So I just wanted to point out some references. Again, the Verigence BIML documentation is available to you right there. Again, mastering everyday XML tasks in PowerShell. You don't have to take pictures, by the way, of the slides. They're downloadable from the past website, so they're already out there. And what I'll do here is later on today, I'll take the scripts that I used, including all the create DDL statements, so you don't have to do anything, but just you'll have to download BIML bids helper from Codeplex and install that, of course. But you'll be able to run all this code yourself. And I'll post that on my blog post at sqlblog.com. Look for my name. And today I posted a blog site where I put up the hashtag for the remote people to ask questions. And all of this will be available there. Again, the last link is to Andy's incremental load package article level 3 that describes that incremental load package. So we've got just a few minutes left. Do we have any more questions? Yes, sir. Okay, the question is the column by column comparison that we used in the filter can be very slow in the real world. There are other ways to do that, be it using like a checksum in each row. That might be a way that there are additional SSIS tasks that you can download from Codeplex that'll generate a checksum for a data row. Put it in the data row, and then when the new data comes in, just check the checksum against it, right? That'll be a lot faster. There are all kinds of different ways of doing that, and you just build that into your model. In another case, before I knew BIML existed, I started this data warehouse project. They need this particular company, because it's a package delivery service. People want to log into their website and find out what the status is of the delivery of their package. So they need near real-time reporting. So in that case, SSIS is not the appropriate tool for that. What I did was I could put triggers into their transactional database that fired off service broker messages, so it kept that trigger very lightweight. I know, triggers, ooh, ah, but they're very lightweight because of service broker. That sends a message over to the data warehouse, and when that message is received, I've got a stored procedure that says, oh, this is what it is, make it look like this, update the data warehouse, and now that information's available. Okay? You had a question, sir.
Yes, MapBasin has easy API. Do you know anything about that?
VZ API. Easy API. No, I'm not familiar with that. Sorry. What's that? The session tomorrow on Easy API. Okay, no. Sorry. Anyone else? All right, please don't forget to put in your evaluations, comments. Thank you so much for coming today. Appreciate it.